Good afternoon, everybody. Welcome to class this afternoon. Thanks for joining me. We are starting Module 2 today. But before we get into some Module 2 information, I want to just talk about Module 1. I have graded your Module 1 lab assignments. And for those of you who are in the other upper level classes that have the same or similar lab, right, I'll be grading those later today as well. You want to make sure that you review those grades and review the feedback for those. Since I used the rubric for that one, you want to make sure that you view that rubric so you get the entire feedback based on what you've done, especially if what you've done ended up less than 100. You want to be able to get make sure that you look at that rubric to get that feedback there. But this week we're starting Git, right? We're examining Git. And Git's actually pretty simple. You know, it looks like one of those things that could be quite difficult, right? But it's actually fairly easy. So as we are approaching what we're going to be doing with Git here, just to allow us to kind of get started, we're going to talk about what Git is, why we use Git. And then as we kind of progress and do some different stuff, I'll show you some other things as to how we use Git. So this first module is an introduction, but we will kind of revisit this as we go throughout the course, add some stuff onto it, right? For the time being, we just want to get acquainted with it. We want to make some accounts. We want to, just get used to using Git. So we are talking about Git here, and just hearing that word, Git, right? You might think, well, what's kind of that about, right? You probably heard of a Git stick, right? When you're telling somebody to get away from here, you're going to use your Git stick to get them away. And I know we're the Yetis, right? But this Git stick won't keep us away. Like if you get that reference, then you remember 5 years ago or whatever, right? But no, we're not talking about something that's going to try to keep us away. We're not talking about something that's going to separate us from things. We're talking actually about something that's going to help us out and help bring things together. Git, in terms of programming, is what we call a version control system. Or it's also known as an SCM, for source control management. We have some code, and this allows us to be able to write different versions of our code, keep track of our code, version out our software. So as we're developing things, we can have different versions that we work on, and we can collaborate with other people who have their own versions that they work on. Right? So this can be used locally or on a server. And the big deal here is that it's a distributed architecture, which means that everybody who is working on the code has their own versions of that code. And if you are working with a collaborative platform like GitHub, which we'll have a quick look at a little bit later, that repository that you have online in the cloud is the sort of merged set of everybody's versions of code that they're working on at the same time, right? So every developer is working on their own version of the code, and then there's other software that can merge it together. And one of the great things about it is that it contains the full history of the changes that were made, right? So if you want to revert and go back, like if you do a bunch of work, right, save a Git version of it, and then you realize, oopsie daisy, right? I've made a big mistake here. Then you can actually go back to a previous version. It's almost like rolling back your operating system in that sort of way. So utilizing Git is extremely helpful, extremely useful for us for these purposes. So, I mean, the big idea here is, why why would we use a version control system? One of the things that we talk about in a lot of our courses is that code is an iterative process, right? We talk about refactoring, we talk about writing things, we talk about making changes to things. You get a baseline that works, and then you can add features, or you can change things that you have to make them more efficient, or whatever you want to do, right? And that's one of the great things about having this iterative process. And so you create a version of your project each time you're working on something, right? And when you push that version into the Git system, into that version control system or source control system, you have a working version of your code, and you can see different versions that you've been working on throughout development. So this allows programmers to make mistakes, right? Because you're going to make mistakes. You're probably going to make a lot of mistakes without worrying that you'll have to completely start over and go from scratch, right? So we can look at it in that sort of way, like it's it's this Super Saiyan Control Z that I call it here, right? A Super Saiyan Control Z, that allows us to look at different things and examine different things. And if we make mistakes, we can go back and we can do something different, which is awesome. Let's see here. Let me advance my slide. And before we get to talking more about, how we use Git, let's just take a look back at the history of Git, how Git was created. So when we look at how Git was created, and we can see here that it's actually relatively new, right? We can see that 2005 there. That's 16 years ago. So this is relatively new in the grand scheme of things. And we can see this individual here that helped develop Git, is attributed as the creator of Git, Linus Torvald, right? Linus Torvald, who was the creator of Linux. So here's another huge contribution from Linus. Gave us the creation of Git. And, Git was born, like a lot of things are born, out of a necessity, right? And I like to talk about this because I think it's a great thing to talk about in terms of development and programmers and all this kind of stuff. When we look at something like the development of Git in relation to why it came about, it kind of gives you perspective as to some things that you could do, right? Because essentially what was happening is, the Linux kernel, right, is open source, which means a lot of people work on the Linux kernel. And you need some way to be able to manage all of these different versions of that source code. Maybe have some sort of approval process about what gets put into the final version, or what is left out of the final version. These are what we call now pull requests, right? We have to have some kind of control over all of this to where I can work on something, you can work on something, those guys over there can work on something. But that's something that we're all working on is the exact thing, and then we can kind of compare what everybody's done and keep what we like and get rid of what we don't and keep these different versions of different things along the way. And so since Mr. Torvalds here was dealing with this huge project of the Linux kernel with all the different developers that were working on the Linux kernel, you could probably imagine that this was a nightmare. So what do you need? You need some kind of version control system. You need some kind of source code management system. And thus Git was born, right? So how exactly does Git work? And this is one of the things that makes Git kind of incredible, right? Because this is really the crux of Git, is the special things that it does when it works. Because, of course, there were source code management systems and version control systems that existed before Git, right? But the vast majority of them worked in a very different way, right? Like if we examine some of the old ways of doing things, you had a checkout system, right? Because you're not able to have multiple people working concurrently on one file. Like concurrency is a huge challenge when you're dealing with, multiple people trying to work on one thing, right? Like it's only within like the past few years, right, that we've been able to kind of figure out the collaboration on cloud documents and things of that nature. And this is even more difficult, right, because we're dealing with code. And so, back in ye olde days of source code management, one of the ways that we would get around this is we would have the file checked out from a central repository. So you'd have a limited number of people, typically one, being able to go in and check out this code from the central repository. They can do their work on it, add things, make changes to it, whatever, and then push it back to the central repo. And if more than one person was working on it at a time and were pushing their code back to the central repo before another version was finished, the later version might be missing changes from the newer version or from the one that was sent immediately before it. It just, it was just junk, right? Like, it was tough to deal with. You couldn't have a ton of people collaborating. Made life hard. But with Git, we don't do that. Things aren't checked out from a central repo. You have your own clone of the repo. So when you're working on your final project, one of the first things you'll want to do as soon as your group leader gets the GitHub repo up and running, you'll want to make a clone of that folder on your machine. And we'll look at how we do that in just a little bit. Right, so you'll want to take that repo after your group leader adds you as a collaborator on it. You'll want to clone that repo. And every time you use that file, you'll want to make sure that you have the most up-to-date version of what's going on in the main repo before you work on things. Right? Because you have your own clone of what's going on. And you don't make changes to anything. You pull these changes from that repo. And so when we ask to change something on our repo, on the main repo, we make what we call a pull request. And so your local repo is essentially just a complete copy of everything that's on the remote server. Your copy of the code is just as good as anybody else's. Right? So as you're making changes and they're making changes, it doesn't really matter the changes that you make, because in contrast to the old checkout method, if you have two people that have downloaded a file and then they're going to upload them back to the central repo where you might lose some changes, in this instance, you can work on multiple files, push them back to the server, and all of the changes that were made go into that central repository because they're all from clones of the main repo. And if you have changes that conflict one another, that overlap one another, then it allows you to make decisions about what you want to keep and what you want to get rid of, because each of those conflicting bits of code come in as cloned elements. Right? So they don't directly impact that main repo in the same way that the old checkout system used to. Right? And the majority of the operations that we do in Git are local. We check them in and we check them out from our local repository. We commit changes to our local repository. And our local repository is what keeps our version history. You know, when we create this copy and we have this clone, it's on our local machine, and that's where we make our changes, that's where we check things in and out, that's where we commit our changes, and that's where we keep things. When you're ready, you take and you push those changes back to the server. To give you a little better idea of how all of this works, I have a little visual here for you as to kind of what's happening. Right? On the server, on that main repo, you have this version database that has all of the versions in it. And locally, you have your own clone of the file, right? Like we have essentially two different computer users here. We have our user A and our user B. They've both downloaded a clone of the files that are hosted here in what would be the most recent version at this point. But really, technically, they when you clone it, you get the current repository. If you clone it with other working versions, you could also do that and have everything. But when you clone it, you're creating essentially your own version database on your local computer of the different versions that you make. Right? So when you're ready to push it back up, you can push back up your changes. And so that's a big deal, right? Like this really helps us to collaborate, to work on things, to have nice, neat source code with version control management. It gives us the opportunity to make mistakes and mess things up without totally ruining everything, because everything is based on versions and clones instead of directly impacting the main files, right? So highly unlikely that you'll break anything for your teammates as you're working on your final project this semester, which is also excellent. But essentially, as we are making a project, we have a typical workflow that we follow, right? We create a project typically on our local computers. So if we're making one from scratch, right? If we're getting ready to make our own repo that we might send to somewhere like GitHub, we start out on our own local computers, making some files and folders. We tell Git what we want to keep track of. And each time our project is in a working state, you know, if it's ready to go, or we're going to walk away from it for a little while and not work on it for a while, we're going to tell our version control system to save it as the next version, to do these commits. Right? So if we ever need to go back to a previous version, we can ask our version control system to revert back to whichever previous version that we need. So I'd like to start us kind of looking at some stuff. But before we look at some actual examples of this, we need to kind of look at what this is. Right, so in order to be able to use Git, you need to have the software installed. If you go to git-scm.com, that's the home of the Git source control management software. Right, and that should also be linked in your module as well. But we can see right here on the home page, we have our latest source release. It does a little funny thing here where it just, based on your operating system, it knows what your operating system is. So it shows you which version. So you can just download the one that's available for you right here and do a full install of it. When you do that full install, it will give you the Git software, and it'll also give you some other stuff. There's a little GUI editor that comes with it, and there's Git Bash, which is the command line editor. And we're going to be focused on the command line editor for the majority of our demonstration. So I've already got this downloaded and installed. So I'm just going to do some of showing this to you from that regard. I believe there's some material in the course that shows you the installation process. Installation process is really quite simple. Mine's already installed, and I've opened my Git Bash, and here is my Git Bash command line interface. So if I want to create myself a new code repository, I'm going to have a project folder. Well, you know what? I'm kind of getting ahead of myself because I want to show you guys a couple lines of code that you need to run as you're setting it up. Right? Git kind of walks you through it as you're getting things set up. But there are some things that you'll want to know here. We essentially have 4 commands that we want to run as we're starting this. So I'm just going to kind of go through each of these. You might want to write them down or make a note of them somewhere. But you can see that mine's already filled out here because everything here is filled out. But one of the things that you'll want to do is you'll want to add a global username. So that's git config global user.name. And in quotes, whatever your username is. I think mine's already been done. But either way, it's not giving me any issues. You'll also want to config it with an email address. So that's git config global user.email. And then your email in quotes. Like that. And you'll want to set, really that's all you need to set. Like there's some other options that you can set through color configuration data. You actually don't have to do that through the command line, even though there is a command for it. If you click on the little icon here up in the upper left corner and visit the options, you can look at the different themes for the color of the UI. And even kind of design your own. Some of them look like, various other things that you might be familiar with. Like the Windows 10 command line. I like using the Dracula one just because I think it's nicer on the eyes. Right? It's a little brighter. And you can also use your own custom colors if you want to. This also gives you the opportunity to change the font size, change some other things about it. Most of these you can keep just default unless you have some things that you like. Right, so that's essentially set up. Those two global configs there are really the only ones that you would need to set. Everything else, we need a project file for us to be able to do it. All right, so I've got a folder here that I've already created. Let me just navigate to it here. So I've got a folder here that I've already created. And I'm going to start Git in this folder. So it starts looking for changes, right? So this folder is on my G drive. So we're just going to use our standard Windows command lines here. So we're going to navigate to that file via the command line, which is, something that you should have been doing in some of your foundations courses, right? This should be something that you know how to do. So we're going to our G drive, and we're going to CD into let me move this over into another window just so I can see exactly what I called the folder. Web140 underscore SP21. And then module underscore 2. So now I'm in that folder. Right, and if we wanted to, we could run our other commands here if we wanted to, right? Like I just ran a make directory test in there. So if I wanted to check it over here now, you can see my directory test popped up in that window, and we can see that there just fine. That's a good way to kind of make sure that you're in the right place. But the first thing that we're going to want to do is we're going to want to initialize Git in this directory so that Git knows to listen to this directory. And so we do that by adding our command git init. So you can kind of think about this as a little mnemonic device, right? And saying that, oh, we're going to put Git in it, right? We're going to take Git and make it listen to this folder. So in order to make Git listen to this folder, we're going to put Git in it. In it here, just like initialize is essentially what that stands for. So we're just initializing Git in this module 2 folder. This is the thing that we want to do to be able to get started here. And so it tells us initialized empty Git repository in this specific folder. Right, and we know it worked in our folder view because we can see we now have a little ghost folder here that's called .git, and that's our code that allows Git to listen in on this folder. So now what we would want to do from here is we would want to do some work in this folder. Right, maybe I use this to create a little website. Let's make a little Hello World website. So let me get Visual Studio Code opened up here. Wants to be slow for me. And let me also switch to my full screen view so you can all see this a little bit better. I need to reboot in a bad kind of way. So now that Visual Studio Code is open here, I've still got my bootcamp files open from last week. We'll open this new folder that we just created. If it wants to cooperate, here we go. I am going to reboot right after this live stream. Because this obviously needs it. So there's the folder that we need. We can select that folder. Yes, I trust the authors. I am the authors. And we'll just create some files in here. Right, I'll create an index.html. And I think that's all I'll do for right now. We'll add a little CSS file here in a little bit. But I'll use my shorthand, my Emmet shorthand here to add. Did not want to. Let's save it. Oh, it's so. My computer's so tired that it doesn't even want to pull up the shorthand. So let's just write our HTML skeleton really quickly. Let's put a title up here. Title is Get Demo. And you know what? Let's go ahead and create that CSS file. We'll call it style.css. And we'll link it in the head of our HTML document here. Link rel equals style sheet. href equals boop-a-doop-a-doo. Come on. Oh, I need to reboot so bad. There we go. Href equals style dot CSS. Now you might notice something interesting here. Which is that we have these green names here that have these little U's beside them. Another reason why I like to use Visual Studio Code is that it integrates with Git. Right? So actually I think it's this bar here. There's a source control, 2 pending changes. Right? You can actually use Git directly from Visual Studio. Visual Studio Code here. So we can see these U's here show that these are uncommitted files, unadded files. And so we can actually use this interface here to work with this, but we're learning by using the command line, which is the best to use because you might end up in a position one day where you don't have that option, right? So we're going to save all of these. And let's put just a little bit of text here. Let's write H1 with hello world in our HTML body. So just simple HTML markup here. Right, so now if we go to our folder here, we have an index.html site. We open that site. We have it. So now we have some changes. Right, and so let's go ahead and add these files and commit these files to our version control system. So what you'd want to do from here is, in order to make sure that you're in the right place, right, one of the things that you might want to do is run your git status command. And this is just going to give you the status of what's currently in the folder. It gives us all this good information, right? On our branch master, which is our main branch, we see that we had no commits yet, right? Because we haven't committed any files yet. And we have these 2 untracked files because we've not added any files to this for Git to listen to yet. So the first thing that we'd have to do before we could commit any of these changes would be to add our files. Right? So in order to do that, we can run git add dash capital A. And this is kind of saying git add all, basically. So this will add all of our files, change them from untracked files, which is what that U is for in the Visual Studio thing, to tracked files. And it'll put them as tracked files in Git in our folder here. So we select that, git add A, and we can run that git status again. And we can see that now we have some files added to our Git to be tracked, right? Those red colored file names are now green colored file names. It knows to listen to them. And this is what we call staging, right? They're staged in our Git. We have them added, but we've not done anything with them yet. We've not committed them yet. And so if we go back just to show you, we go back here, we look at our version control system here, we can see now that those U's have changed to A's. Because they've been added, but they've not been committed. And we can also see the differences if we click on each of these little things here, which is pretty cool, right? But again, we're doing things the command line way. So now what I want to do here is I want to, maybe I'm happy with this version, right? And I want to go ahead and commit it. Okay, so I want to say git. Let me zoom in here. The next thing we'll do is we'll git commit -m. We always want to do -m here because -m is for message, right? We want to give a message with our commits, so it is descriptive as to what we did with this commit. So this is our first commit, and typically your message for your first commit is going to be just first commit. Right? Whenever you change it in future versions, you might have to, or you might want to write something more descriptive there, like this is, something about what you did, right? Which we'll do in just a moment. Right? So now we see that we have this first commit made, and we can see the changes that were made, right? We've created this index.html, we've created this style.css. And it's given us it's essentially established a version in our local version control system. Which is good, right? This is what we want. So now, let's go and make some other versions, right? So let's go and make, if we go back here, we see these update now, right? Since those changes are committed, and this is a version that you remember that U changed into an A, and now that A has disappeared. What I want to do is I want to just add a little bit of code here into our style sheet just to change the color of that hello world, right? So we will change this to color green. We'll start out with color green here. And then we'll save. And now that we've changed, we see we got a yellow file name here, right? And an M here. Because this file has been modified, but this modified file has not had the version changed yet. So we need to do the same thing here. We've already added all of our we've already added all of our files. We haven't added any new files. So Git's still listening to these files, right? So if we run a git status command here, it'll see that we have these changes modified and made, right? We've modified our style.css. We want to update what will be committed, so we'll say git add style.css. So now, since we're just doing that one, we can just focus that one. Or we can do the git add dash capital A again, right? And then just git commit dash M changed H1 color to green. And now we can see we've got our git commit in there. We have our version here, which is going to be important to us in just a little bit. Right, that EEF C9D6. Right, if we go back up here on our revert, or on our create, we see we have a version number here for that master root commit 64BDF69. These are numbers that we're going to have to pay attention to as we're going throughout, going throughout our situation if we want to kind of go backwards and revert to an old version. So I think the thing that we might want to do next is just do that again, right? Just give ourselves another change, another commit here. So I'm going to go in here to my CSS, right? If we go in here now, we'll see that yellow and M go away. We'll change it to red. Save that. We'll see that yellow and M come back here in just a moment. There it is. And then we'll just go in here and do that same thing that we just did again. We can use our up key, right, to just do the same, to recall the same files that we did previously, or recall the same commands, rather, that we did previously. So git add style CSS, git commit, change H1 color to red. Now we have another commit and another commit version change here. Now, if you do a bunch of these, you probably will forget. And what we could do is we could take a look at our git log to see all of our changes to all of our commits. Right? And we can see that we've done our first commit. We've changed the color to green. And we've changed the color to red. We could also run git diff. Let's see, what else did I need to add to that git diff? Git diff shows you what's been changed, but hasn't been staged yet. So since I've already committed this, nothing comes up with git diff. But if I changed something, then it would show us the difference there. So if we want to go backwards and go back to, let's say we don't want it to be red, right? We want it to be green. right? Like if we go into our site here now, we'll see that our code's red. Before it would have been green. So let's revert it back to when it was green. So in order to do that, we need that hash that I was pointing out to you as that version number earlier. So in this case, I would need the hash from the commit that we changed this to green. And if we look here in this get log, we can actually see that it's the first 7. I believe the hash that we want to do our checkout is going to be the first 7. Right? If we go back up here, we see that it's let's see, where's it at? Where's it at? Where's it at? Where did we make it green? Here, right? EEF C9D6. If we go down here, we have EEF C9D6, right? It's the first. We could use this whole thing if we wanted to, but really all we really need to give Git is enough to understand which commit we're going back to, right? And so in order to do this, we are going to use our checkout command to go backwards. So we're going to check out that old file. So let's go to here. Let me zoom in. Let me take these 1, 2, 3, 4, 5, 6, 7. We'll take these here. We'll just copy them. Actually, I think I can right-click copy. Yeah. And so I will git check out. Right-click paste. I don't think I'm forgetting anything here. I don't do this a ton, if that gives you any indication. Let's check this out. You're in the detached head state. You can look around. Yeah, we need to do... Head is now at... Okay, yeah. Head is now at EEF C9D6. So we've reverted. This worked. Right, and if we go back here, we see it's changed it back to green in my code window. Right, look at there. It was red. Now it's green. If we go to the live site that we have down here and refresh it, we see that it changes to green. Right, ideally you would use these with branches, but we're not going to worry about that here. That'll be something that we kind of worry about a little bit later on. I might have another video that I put out alongside this one where I do an example of pulling some code. Because typically in order to do that successfully, I actually have to add stuff to somebody else's open source code files, which are a little bit different. Right, well, we can see that we've checked out this version. We've brought that old version back, right? The other versions are still there. I still have those versions there, right? Like I could go back to the red if I wanted to by just checking that out as well. Or I could go all the way back. But now that we have this, we're at a point where we can push this code online. And that'll be the next thing that we do. So we're going to kind of run through some of this stuff pretty quickly just because we're getting toward the end of our hour. And so to push this code to a central repo, there are all sorts of different websites that use like the Git software to push code to a central repository. But the most widely used one is GitHub. Which is here. Right, so GitHub's a free account, right? We can all use GitHub for free. We can see that all sorts of enterprise businesses use GitHub. Basically all of them. All of them that don't have their own private repos, right? We can see that Ford, Autodesk, Pinterest, TensorFlow, Home Depot, Adobe, Spotify, Docker, Stripe, 3M, Etsy, all here on GitHub. You'll just sign up to create your account, and then you'll sign in when you've got that ready. So I'll just log in here. Let me try my email address. I was just logged in. I shouldn't have logged myself out. Give me just a moment here, everybody. Let me put the starting soon screen back up and turn the music back on while I'm getting this sorted really quickly. Give me just a moment here. All right, there we go. That's a little embarrassing. I just logged into it just yesterday so I could post code to GitHub. But apparently, my memory is worse than I thought it was. So now we're on GitHub, right? So we want to use this as a central repository to be able to send this code to that we've been working with on our local machine. So what we're going to do is we're going to create a new repository. We're going to use this green new button here, create a new repository. We're going to call it, something different, right? Like you'd have to call it something different. We'll call it SP21 get_test. We can add a README file if we want to. We can add a git ignore if we want to. For our purposes in this course, neither one of these are important. Add a little description if you want to. And this is fall 21, not spring 21. This will be git test for fall 2021 web 140 course. And I can just click here to create the repository. And it'll spin us up a repository in a minute or two. We'll get to there and we'll see what all we need to do here. My browser appears to be hung up because I need to reboot. There we go. This is what your brand new repository looks like. And it actually tells you some things that you need to do. Like if we look in this first block here, right, we see git init, git add, git commit, git branch. We've already done half of this just on our local machine, right? Everything else we would need to do now to be able to push this from our local machine here, right? So what I'm going to do is I'm going to go ahead and take this line here and copy it. And then I'm just going to follow everything from git branch down, right? So I need git branch -m main. And this is telling us our branch is named head. That's because we used that, what was the command? The checkout there. So it's called head. No big deal. I don't even think we actually have to do this. Git remote add origin. And we add this remote origin on GitHub. That's the link that we copied there. And now we can push from our head to the online, which will be git push -u origin main. We'll give it a second to let it do its thing. Oh, you know what I think the issue is? We never we checked out that file. But we didn't commit it. Again, those checkout things, they're not something that I do a lot. So we need to git commit or let's create a new branch here. That's what we would probably want to do. Is create a new branch with this reversion. It's something that I don't do a whole lot. So let's create a git branch new _ branch. We can call it whatever we want to call it. And so this is the point where we would want to Git commit. Says the working tree is clean. Let's push new branch. Oh, I have to switch. I have to switch to the branch. I have to switch to the branch. What is that command? Don't do this unless you absolutely have to. I don't. Oh, what is it? What is it? What is it? What is it? But I need to run the rebase command here. Git rebase. New branch. Says it's up to date. Let's try to just push it from here. So that would be git push origin, which is what we named our online repository, new branch. Let's just troubleshoot this really quickly while we're at it. Okay. There we go. You know what we forgot to do? Is we forgot to add. Right? So when I went through and added, my git push origin branch or git push origin main worked. So now I should be able to refresh here and I see all my files. Right? And you can see the commit names here. And we can actually see that 2 commits have been made. So I can actually go in here and look at them. And these are the commits that we made on our local machine. Right, so now let's look at pulling that back down. Right, so if you're going to this as someone who wants to make a clone of this, right, what you'll want to do is you'll go to the repo. You'll drop down here by code. You can see it's HTTP. Right here it is. I am going to go back to here, go up a level, create a new folder, module to pull. And we'll pull this code like we're a new user back into this folder. So now that we have it online here, we're going to pull it back down. So I'll just CD to go up a folder. CD into that module to pull. I'll initialize Get in this folder, so Get init. And now I will Get clone at our remote location, which is the URL that we copied, and it'll pull it down. So now I have a copy of it in this other folder, right? We have Fa21 Get test here. Right, so I'd want to CD into Fa21. What was it called? Underscore get underscore test. So now I have all my files here. I can see the branch name that I'm on here, which is called new branch. It pulled that down. I can open that folder in VS Code. I can make changes in here. Yes, I trust them. I am them. I can change this to blue. Right, so now we're treating it like we are a separate person. So if we go into that folder, we're in it here. We see we have our .get folder here. So it's already listening to this folder. We would just go back in here and make the push, right? So we would get add everything, get commit -m, changed h1 to blue. Oh, we use the uppercase M instead of a lowercase m. Specificity is important. It's getting late in the day. Get commit, changed one to blue. Since we're on the new branch, we will get push origin from new branch. Otherwise, we'd be pushing from our main branch. It would help if I spelled it correctly. It's getting really late in the day. It's new underscore branch. Is that what I've been doing wrong the whole time? Seems to be. Yep. It helps if you put the right name in there, of course. So now if I go back to my GitHub, I can see changed H1 to blue. Since I'm the same user, it's not going to ask me for a pull request. But if you have different collaborators and things like that, it'll put these in as pull requests, which we'll look at a little bit later. But before we go, like we've run a little long, but we need, that's because of troubleshooting and just me being tired, apparently. I want to show you guys Github Pages, which is all going to be important for later on. If I go into my settings here, I can find here on the left-hand side a little thing that says Pages. I select the source branch. In this case, it's new branch because I changed the name of my branch. and I click save. And now that I have that website online. Remember that if you change your, or if you name your HTML file, your main HTML file for that branch, index.html, you won't have to put another file extension on this. It'll just work, right? Like that. Like say we get this site ready to be published. This is a website live on the internet. If you name your HTML file anything other than index.html, you would have to add the file extension onto the end of this URL for it to work. It won't work by default. So that's pretty cool. All right, that's all that I have for you for this video. I'll try to post another video that I've made previously that shows this a little cleaner as well, since we did have those few errors in the middle there. But if you have any questions and you're watching this later, please let me know and we'll work through it. You know, one of the great things about GitHub is there's a lot of resources for it online just because, you know, everybody uses it. You remember that you don't have to change your branch name. You don't have to do some of that stuff that we were doing today. You know, you can just leave it as main or leave it as whatever. That's all that I have for you for today. Thanks for watching. We'll see you next time.